lab up to the topic which are covered in our theoretical syllabus. Okay, is it clear? Now we are not going to discuss any theoretical part. We are discussing about the virtual lab IA conducted by the IIT Mumbai. So now I'm sharing that particular screen. We can wait for a couple of minutes. So I'm going to sharing the virtual program and explaining what is done in the virtual lab. Okay, today we are discussing about some of the programs which is going to be executed in the virtual labs, but actual lab will be conducted only through the Octave by writing the program and everything. But this virtual lab is an additional topic which you are giving to you. Okay, just a second. I'm going to share the virtual lab for the image processing. I hope that you're able to see the screen. Anyone, just we can reply to me through chat. We can able to type the message or able to see. The screen is visible to you.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine, fine. We can see the distance and connectivity where we are able to find the distance between the two pixels and we are able to find the path between the two pixels. That is the first program. The image arithmetic is nothing but is a spatial domain operations. We are able to perform arithmetical operations and logical operations. Now we can able to say image histogram. Then you can able to see the Fourier transform. So these are the topics we are overview of this topic. Okay, because here there is no programming, just we can able to visualize how it is working. The first thing, distance and connectivity. It discuss about the pixel neighborhoods. I'm showing the output. Some of the topics will be covered in our syllabus, some will not be covered. We want to focus only the syllabus which is covered. Okay, we already studied about how to find the relationship between the neighbor pixels, top, bottom, left, right. These are four neighbor pixels. n4 of P. The next is 8 neighbor pixels, including the diagonals. That we can represent n8 of P. Then is m neighbors, mixed neighbors. Sometimes will be one will be the diagonal, another will be the bottom. Like it is a mixed diagram. Okay, this is a thing we are discussing theoretical part. In experiment part, just to complete the experiment, we are going to measure the distance between two pixels. So these pixels will be able to as a three methods. One is city block, chessboard, Euclidean distance method. The Euclidean means where you are able to give the radius according to that the image will be the distance between two images will be mapped. Chessboard means it is 8 blocks. City blocks means you can consider as the 4 blocks. Okay, these are things we are discussed in previous lecture. That is in the theoretical part. Now I want to find the distance between two pixels. So here I'm going to select the start pixel as well as end pixel. I'm going to select the start pixel. If I click here, we can see x comma y is 0 comma 0, the starting position of the pixel. The next is this pixel. I want to submit it like this. So I can able to see x is equal to 4, y is equal to 0. So x, y. X is 0, 1, 2, 3, 4. It is a fourth column. Y is a 0. So the position will be like this. In this, we want to find the distance between the two pixels as well as we want to find by using the city block method, chessboard method, or Euclid method. The three types are having the three different formulas. Okay, now I'm just going to measure the distance between two points. Okay, by using a Euclidean. There is a first method by using a formula. Just a click run. We're able to give the distance between the two selected points is 4 units. One, 2, 3, 4 units. If you go for the another example called chessboard, I'm not changing any position, just changing into the chessboard method. Just I'm going to use run. The distance will be the 4. Same like the first city block run. It is also 4. Now I'm going to change the pixel positions. I'm not changing the pixel position 1. I'm going to change the pixel position of the end. Okay. In this way, I'm changing x is equal to 0 comma 0, ending position is equal to x is equal to 3 comma 3. Now I want to find the distance between these two pixels by using a Euclidean method. The another is a chessboard method, another is a city block method. Take your run 4.24 units for the Euclidean method. Chessboard method, we can able to click run, we can able to 3 units. If it is a city block method, we are able to see that this is 6 units. In this way, we are able to find the distance between two pixels. This is the first experiment. We are already discussed the theoretical part. Now it can be done. This distance will be calculated by using these formulas. I'm showing the formula. Where is the formula? The formula we are discussing the theory part is available in the PPT. According to this formulas, this method will be executing. Wait, I'll be sharing the formula. Just a second. I'll be share the PPT with you. Just a second. Just a second. I'm opening the PPT so that the formula will be that how to find the equivalent distance, how to find the crossboard, chessboard method. Okay. Okay, now I'm sharing the PPT where we are discussing about the distance between two pixels formulas. Okay. Yes, you can see the distance measured between the two pixels. There is a three types of distance. One is Euclidean distance, city block distance, chessboard distance. Okay, if it is city board means you're able to go for the 4 pixels. If it is chessboard means you go for the 8 pixels. By using the formula, we are able to find it. Okay, giving in formula for that. Here you can see this is the formula where we have discussed. To find the distance between the two pixels, we want to use x comma y. Starting position, the ending position. Is it clear? Okay, by using this formula, they are able to find the Euclidean distance, city block distance, and chessboard distance for the distance between two pixels. Okay, in this they will not give any coding for that. That directly they will be see how it will be working. The program will working in the graphical user method. The program will working in the graphical user method. The next we are going to see about the next program. Next is image arithmetic operations. The image arithmetic operations nothing but we are going to perform the arithmetic operation between two images. Here the images means the image will be converted into the matrix, then the matrix will be able to perform addition or subtraction. It is most important that you are not making any individual value, we are going to perform the matrix addition subtraction. We can see one by one. Okay. Addition, subtraction, difference, multiplication, and division. Okay, now we can able to see the image is going to taken and perform some addition subtraction will be there. There will be the two images. One image will be where you are giving a input original image. The second image where you are giving it is a mask image. So the original image will be there, the mask image will be there. You want to perform the addition means each and every component, every value in the matrix will be perform addition and will be get a new image. That image is called the answer for the addition image. Okay, again I'm repeating, these images will be taken, converted into the matrix format. Same like that, the mask image is also taken, converted into the matrix. Then the matrix addition will be performed. The resultant matrix will be able to give the output of addition of two images. So one image is the original image. The second image is the mask image. Okay. So according to this, I want to select one image. I'm just going to select an image. This is an original image. So we can select any one image. So I'm going to select this car image. You can see it is an original image. Now I want to select the mask image. The mask image is nothing but it will be generated by any one brightness fully small portion of the image. It is a mask image where it can be consists of full black or full white or it may be a gray color. You can see here the second mask image will be in the form of three colors. One is dull, bright, and gradient. I'm choosing a dull color. The dull color means this is the image where it is going to be used for the mask. This original image is converted to the matrix. This mask image is also converted to the matrix. I'm performing the addition operation and going to run the image. If I click it, you can able to see this is a primary image. You can see this is a primary image. This is the mask image. This is the mask image. By performing the addition between two images, we are able to get a processed image. In this addition, we are able to see the images brightness is improved. It is one type of image enhancement. If the same image, I'm taking the same image, I reset it. I'm going to take the same image. Okay. Now I'm going for the addition only, but the mask image I'm going to is change it to bright. I'm going to change the bright now. Most of the colors will be in the one. Values in the pixel intensity values are will be in one. Now select the addition. and going to run this program. Now we can see the original image is the secondary image, the mask image, where the process image is over brightness will be there. Somehow the image is enhanced by giving a more brightness. Same way, you are able to choose the gradient of white and of black. We are going to run the program. We can able to see it gives the image the contrast stretching image. It gives the image the contrast stretching image. So in this way, by using the arithmetic operation, we are able to enhance the image. The image can be enhancement, gives a more detailed information of this image. Okay. Now I'm going for the dull. The mask image will always, there is a two image. One is the original image. You can go, one is always, it is the original image. The second is a mask image. Here the mask image is a dull image. Now I'm going for the subtraction. Now I'm going for the subtraction. I'm going to run the program. If I run it, we can able to see the image somewhat is enhanced. You are able to clearly identify the edges of the image. Clearly identify the edges of the image. This is one type of program where original image will be separated with the secondary image. That is a mask image where it is dull color. Then the processor image will be there. Same like that, if you go for the brightness and run the program, we are able to see that the original primary image will be there, secondary image is the brightness, so you can perform the subtraction operation, you are able to get the image will be very done. Okay. Now I'm going to for the another operation called difference operation. What is the difference between these two running? We can able to see the difference between this image. Okay, the difference is nothing but it is also one type of suppression only. It tells that more detailed information of this image. Okay. Now we can go for the multiplication of this image. I'm going to run this. So if you multiply the original image with the secondary mask image with 0, the output is also white. Now I'm just changing the mask image is the brightness and try to run the program. Again, it will be like that only. Okay, fine. Now I'm going to for division. Okay, go for the dull from the image. Okay. We want to, I'm clearly informing only one point here. Whenever you are performing an arithmetic operation in the image, the arithmetic operation means the original image is converted into the matrix. It will keep that. Then the mask image, that is a secondary image. Mostly it is called as a mask image. It is also converted into the matrix. Then these two matrix will be performed the addition operation. The resultant matrix will be able to convert that matrix into the image so that you are able to get the image enhancement after the arithmetic operations. Okay, these are the things we have discussed in the spatial domain. These are the things we have discussed in the spatial domain. Now, now we are going to discuss about the another program. This experiment will not able to give all the explanation for this program. It will give only the part of the experiments. So we are discussing what are the things we have studied in the theoretical part, how it can be applied. That is the thing we are going to study. Okay. So image arithmetic operation is completed. Now I'm going to move to the image histogram. where we have studied about the histogram and histogram equalization in our laboratory class. So here we are going to discuss about the histogram. Okay. Now we can able to see, before I'm going to uh, run the experiment, we want to see the output will be displayed in the form of the chart, where we can able to see in the x-axis will have give the value ranges from 0 to 255, meaning that the pixel intensity value will be starting from 0 and ending from 255. So wherever it is a 0, it is a black color. Wherever it is a 255, it will give the brightness. Okay. In y-axis, it will be gives the value for the frequent of the pixels, the frequency of the pixels, meaning that for in an image, the reason pixel intensity value is 100, it will count how many times the 100 is available the entire image. How many times the pixel intensity value 100 is available in the entire image. The count will be pointed in the y-axis. 100 in x-axis, and that is the pixel intensity value is 100. This 100 is how many times it is available the entire image. That is the frequency of the pixel. It will be displayed by pointing that we're able to draw the diagram, histogram. This is called the histogram. So I select the full histogram. Histogram is selected. I'm going to select an image. I'm going to select the image car. Then going to run the program. So you can able to see the histogram of this car. The minimum pixel intensity value is 2. The maximum pixel intensity value is 254. In minimum 2 means from 2 onwards it will be starting. It will be stopped at 254. It will stop at 254. This ranges are denoting that the particular position, the pixel values are this much time. For example, it is a 180 means 180 pixel intensity value is how much times it will be available in the image will be displayed here. Now I'm going to take another image for the reference. I'm going to take another image and performing the histogram. Okay, if I click, the histogram will be displayed here. The minimum is 0, the maximum is 253. Okay, in this way, the histogram will be, the image will be converted into the histogram, where the x-axis will have the pixel intensity value as the units. In y-axis, the units are displayed in such a way that frequency of the pixel intensity values. The frequency is nothing but the number of times the particular pixel intensity values is there. That value will be plotted in the graph. This is about the histogram of an image. This is about the histogram of an image. This is also studied, and we are able to experiment in the Octave also by writing the coding. Okay. Up to this, we can stop today, because what are the theory we are discussed, we are able to execute the program in the virtual lab. Okay. Now I'm requesting each and everybody to drop the enrollment number for the attendance. Okay. I'll be telling how to give the feedback in the virtual lab, so that it will be recorded and submitted to the department. Okay. I'll be tell separately to you. So those are given enrollment for attendance. Just we can leave the class.
Hello, sir.
Yes.
Sir, by mistake, I typed 289 instead of 29.
Yeah, okay, fine. I'll be checked. Not an issue.
Sir,
Yes.
I have written true number also. Okay.
Yes. I
Thank you, sir.
noted.
Hello.
Yes, ma'am.
Hello. Good morning, sir.
Yeah, very good morning, Ash.
Sir, I wanted to know, can you please suggest some topic? Because I am planning to write research writing. So
Okay,
can you
fine.
please suggest some topics so that on which I can write a research paper? I want to publish it on IEEE.
Okay, fine. Regarding this, just we can discuss after 2 o'clock, no? Do you have
Okay,
my
okay.
mobile number?
No, sir, no, sir. Actually, I
Okay.
searched in Google, but I didn't. Can you please share so I can save?
Yeah. I'll be sharing here.
Okay, sir.
Okay, just you can see your chat box. It's
So
my number.
where will be
Just you can,
more? Can I contact on call, WhatsApp, or Telegram? Where?
yeah, you can drop in the message in WhatsApp,
Okay,
or you
okay,
can make a call. Not an issue.
okay, okay, sir. Thank you so much,
Okay,
sir.
fine. Thank you.
Yes, sir.